Hello and welcome to Empowered Learning. This video will be about using determinants via Cramer's rule to solve systems of linear equations. So this first question asks us to look at the linear system of equations and use Cramer's rule to solve the system. So really what this problem is trying to ask us to do is just set it up. And so we need to talk about what Cramer's rule says. So if we take this particular system and write it in this matrix form, it'll look like this, where we first form our coefficient matrix, and then we have our variable matrix, and then we have our answer matrix. And of course, if we were to multiply these two matrices here and then set them equal, then of course what we would end up with is this again. So what we're going to call this matrix here is our coefficient matrix, but when we use Cramer's rule, we want to be able to use determinants to be able to do it. So what Cramer's rule says is if you want to find the variable x, and that means the variable that goes with that column, and of course this column would be considered the y column, then what you need to do is find the determinant of the coefficient matrix with respect to the x column divided by the determinant of the coefficient matrix itself. And so what the determinant of the coefficient matrix with respect to the x column is really, and this is 1, 4, not 14, by the way. And what this is we're going to replace, sorry, this is 14 and not 1, 4. That's what I meant to say. But what we're going to do here is take this column, our answer matrix, and replace it with column X. And so when we do that, we need to get the determinant of 14, 57, and then we just do 4, 8, like that. And of course, the determinant of the coefficient matrix itself is just the determinant of all of this. So of course, we know when we do this, we'll be doing 14 times a negative 8 minus 57 times 4 to get the actual number there. And then of course, for the denominator, 6 times negative 8 minus 5 times 4, which is 20 there. So of course, this is how we would set that up. For the y variable, we would do the same thing, but now we would stick the answer column matrix into what y is. And so in place of this 4 and this negative 8, instead of keeping the 4 and the 8 there. So we would have 6, 5, and then 14, and 57. And then after that, of course, the determinant of the coefficient matrix is still the same. And so that is what this is asking us to do here. So we'll do this. We know that we're going to have a 2 by 2. So that'll be 14, 57, 4, and negative 8. And then of course down here, we would have another matrix, or determinant of a matrix. And this would just be 6, 5, and then that's 4, negative 8. And we'll go ahead and copy this because that's going to be the same thing that's there. And then here we'll just change out here to 14, and this number here will be 57. So this is how we would set up Cramer's rule to be able to solve for x and y. Okay, so now we'll move on to our next question. All right, so now for our next question, we want to use Cramer's rule to solve the system, or to determine that the system is inconsistent or contains dependent equations. And of course, now what that means is if the system has solutions, then we're going to find out, we're going to find values for first of all, for D, which is the determinant of the coefficient matrix, we will also find out that if the system is inconsistent, then that means that our value for the determinant of the coefficient matrix will be 0. Okay, and then of course, if we find a situation where we have duplicate solutions there, then we'll see that in that case we have dependent equations. Now, just looking at this, we can kind of tell that we don't have dependent equations there because the slopes of each of those lines are totally different. Okay, so what we need to do is just calculate what the determinant will be, as well as the determinant with respect to the x column and determinant with respect to the y column. So we'll make some room here and then calculate that. All right, so first thing we'll do here is just set up what the matrix equation would look like to begin with. And here we need to switch that. That's a positive 1, not a negative 1. And this will be x, y, and then this will be 8, 4. And we'll make that 8 look a little better. All right, so here's what our coefficient matrix is. So we got 1, 1, 1, and negative 1. And then, of course, our variables x, y, and then our answer matrix, which is just 8, 4. So, of course, D is just going to be the determinant of the coefficient matrix, which will just be this. And, of course, 1 times negative 1 is a negative 1 minus 1 times 1, which is 1. So that gives us a negative 2. So we know definitely the system is not going to be inconsistent. Whenever we look for the determinant with respect to the x column, we're going to replace the x column, which is this column. Instead of 1, 1, we're going to have 8, 4. And so we'll replace that. And we do the determinant. So that will be 8 times negative 1 is a negative 8 minus 4 times 1, which is 4. So we get a negative 12. And then, of course, determinant of coefficient matrix with respect to y, instead of 1, negative 1, we replace that with 8, 4. So we have 1, 1, 8, 4, and get the determinant. 1 times 4 is 4, minus 1 times 8 is 8. So we get negative 4 as an answer there. And so this is what we should be putting in here. Okay, so then the solution set to the system would be as follows. So we know that for x would just be d sub x over d, which in this case is negative 12 over negative 2, which is a positive 6. And y would just be dy over d, which is negative 4 over negative 2, which is a positive 2. So our solution set is 6, 2, or those two lines intersect each other at the point 6, 2. All right, and so we'll move on to our next question. All right, so for this one, we're just given a system of linear equations, and we're asked to solve this via Cramer's rule. So again, we know that if we write out the matrix equation equivalent of this, this would be a 4, 3, 2, negative 4, x, y, and that would be 9, 4. And so now we know that D is going to be the determinant of the coefficient matrix itself, which is going to be this, which would be a negative 16. 4 times negative 4 minus 3 times 2, 6. So that's a negative 22. Derivative of coefficient, not derivative. The determinant of the coefficient matrix with respect to the x column will be replacing, since that's the x column and that's the y, we're replacing 4, 3 with 9, 4. And then do that with 2, negative 4, and then just find the determinant of that. So 9 times negative 4 is a negative 36, minus 4 times 2 is 8, and that gives you a negative 44. Okay, well, let's just do that all over because that doesn't look too good. All right, and so now determinant of coefficient matrix with respect to the y column, we just replace the y column with 9, 4 now, and keep the x column the same. So 4 times 4 is 16, minus 3 times 9 is 27. So from there, that should give us a negative 11. So from there, we can figure out what x and y are. So x is just dx over d, which is negative 44 over negative 22, which is 2. And y is dy over d, which is negative 11 over negative 22, which is positive 1/2. And so that should be what our solution set is. So let's go and do that. 2 and then 1/2. All right, and so now we'll go to our final question. All right, so for this last question, what we're asked to do is come up with the system of linear equations based upon the determinant of the coefficient matrix and the determinant of the coefficient matrix with respect to the x column. And so here we know that when we talk about the coefficient matrix itself, that gives us all the coefficients that we need. So of course, this will be our x column, that will be our y column. So we know we have 5x minus 8y, and we have 3x plus 2y. We know that. So now we know that since this is the determinant of the coefficient matrix with respect to the x column, then we know that this column was replaced with whatever is on this side here. So this would end up being 5, and that would be 3 there. And so it just so happens that what the coefficients are for the x column and what the coefficients are for the answer column, or the answer matrix, if we wrote it in matrix equation form, would be the same. So in doing this, we would have 5x minus 8y equals 5. And then the second equation, 3x plus 2y is equal to 3. And that concludes the videos on using Cramer's rule to be able to solve systems of linear equations.